Well, hello, class. Hope your week is going well. We're on week 3 now, and I mean, let's face it. You blink your eyes, it'll be Thanksgiving. Blink your eyes again, it'll be Christmas. So it's gonna start moving quickly again. So first of all, I wanted to report to you about my vaccine. I had a pretty strong response to it. It took me about 4 days to recover. So I got on a Thursday. Friday, I was pretty worthless. Saturday and Sunday, I was pretty worthless too. I slept like a cat. I was sleeping all the time. And then Monday, I was starting to get better, but I didn't. My athletic abilities were pretty low. I usually run almost every day, and I lift weights also 4 days a week. So if you're ever in the Warrior Rec Center, that's where I typically lift weights. So if you ever are there, please feel free to say hi. But I wasn't really able to exercise on Monday. So I did as I normally do. I made a blanket fort. So here's my blanket fort. This was made Friday, and I named it Fort Mosey. I always name them after cats that I've fostered. So I used to volunteer at the Maui Humane Society, and I fostered some kittens. So here's Mosey. So here she is. So she's this cute little kitten right here. So there you go. So aptly named after the forts are named after kittens. So Fort Mosey for you right there. Okay, but I did want to talk to you about the James Webb Space Telescope. So currently we have two space telescopes, the Hubble Space Telescope and the James Webb. And this actually is important for us in Hawaii because astronomy is pretty big in Hawaii, because the Big Island is one of the three best sites in the world for astronomy. And unfortunately, with the James Webb, this is kind of spelling the end of astronomy in Hawaii. So, depending on who you ask, I mean, some people are very pro astronomy here in Hawaii, some people are against, and there is quite a bit of controversy regarding the 30-meter telescope and its perhaps construction on the Big Island. And unfortunately with this, though, even if the 30-meter telescope were to be built, it would be obsolete because the James Webb is just so much better. There are some things. Hawaii is still good right now as far as the telescopes there, and it's still a wonderful place to do research. But like I said, we are now having better telescopes. And this is a problem for Hawaii too, because of the nature of the state. Hawaii doesn't really have that many natural resources. So like Ohio, for instance, where I'm from, there's quite a bit of coal. So coal mining is a fairly big business in Ohio, and there's various other things that they do in Ohio. It's a pretty big, powerful state. Although there's a joke saying that a lot of astronauts come from Ohio, and the joke is like, well, if you live in Ohio, you're okay with leaving the Earth. So I personally do not want to move back to Ohio, but it is certainly where I'm from. So Hawaii, contrast to other places, doesn't have very many natural resources. What Hawaii has is position and weather. So that's the main thing for Hawaii. And then, of course, the biggest industry that we have in Hawaii is tourism. It's a quarter of our economy. And although many people don't talk about it, the military presence. So Pearl Harbor, and then everything there, the other bases around Hawaii, is because the position that we have in the ocean. Whoever owns Hawaii owns the Pacific, basically. So its military presence is very strong. So, and it makes us, for our economy is very based upon that. And with our resource, the position and the weather, telescopes are great here. So it's not just on the Big Island. Haleakala on Maui hosts various telescopes. So the Deakest, that's a solar telescope, for instance, and also the Pan-STARRS. It's a Pan-STARRS is a telescope. It just takes a picture of the entire night sky, and it looks for things like asteroids and comets and that kind of thing. So that's actually part of our planetary defense, because one of the things that could potentially wipe out the human race is an asteroid or a comet. So, okay. So now let's talk about the James Webb Space Telescope, and there's some really cool things that have come from it. And it has a couple instruments on it. It's not just the images. It can also take spectra. So molecules, they behave differently when they get exposed to different types of light. And in the James Webb Space Telescope, it is an infrared telescope. So it observes things in the infrared. And when infrared light interacts with matter, it causes the molecules to vibrate. So like if so carbon, oxygen. So if you hit carbon dioxide with infrared light, it'll start to vibrate like this or like this. Just depends on the different modes and the different frequencies of light. So because of this vibration, and it's linked to the photons' energies, you can tell whatever is there. So meaning carbon dioxide. Another thing, carbon dioxide here on Earth is the same carbon dioxide that's out in space and different planets. So the elements that we have, the 118 elements of the periodic table, and then the combination of those elements, that's true for everything in space. There's no new matter in space. So the carbon dioxide, the methane that we have here on Earth is exactly the same as, and it behaves the same way as these in different planets, exoplanets outside the sun, for instance. So there are some cool things, like I mentioned quartz clouds. So quartz, it's a mineral. So we don't really think of something like a cloud made of quartz. So and this talks a little bit about it, and specifically talks about methane. And so we see methane in other other planets, even in our solar system. So for instance, Uranus and Neptune. So those have quite a bit of methane in them. And so I'm seeing all the connections here. Another thing that's interesting about this, so methane is an organic molecule. It's carbon containing. And there is something called the abiotic hypothesis. So we use the term fossil fuel quite a bit, but pretty much this is one of the, like, if you're wondering where science is going, fossil fuels, what we call fossil fuels, is that term, although we might still use a term, the idea that gases like methane are from a biological process, or primarily from a biological process, that is something that's going to go away. I mean, so the methane is primarily, the abiotic hypothesis, methane is primarily made in the Earth, at least here on Earth. It's primarily made by other chemical processes, not biological. So I know we refer to natural gas as a fossil fuel, but it's really not a fossil fuel. It's very, very, very highly likely that methane and petroleum are not from dead dinosaurs. So it's really made in the Earth itself. And that's something that we're going to see in the future, and that's something like, it's going to, like, I mean, we change, our knowledge, and we change things. So, like, I mean, now we talk about dinosaurs, we think they had feathers on them now. So, I mean, if we didn't know that before, kind of thing. So, I mean, science changes, science evolves, and and this idea of a fossil fuel, and that's going to go away. I mean, there's just it's too obviously wrong. And I mean, you can see this, that we're finding methane, outside of the solar system as well in great quantities on exoplanets. I mean, does that mean that this planet is the proof of life? No, it's not. You see nothing on here in this article saying, like, we found life or fossilized life. Like, no, this is not a sign of life at all. It's actually expected. And just like we are not finding, or at least not yet, a life on other solar planets, like our solar system, like Uranus and Neptune, for instance. So this article mentions how unique the Earth is. So the Earth is a pretty unique celestial object, and we are very lucky to live in such a beautiful and wonderful planet. So of course we need to care for it. So, but yeah, no, I think this is an interesting article, and I think it's interesting because of us in Hawaii, because especially in the Big Island, there is a large part of our economy that is based around astronomy, and the university, we get a lot of grant funds based off of astronomy. So astronomy is a major money maker for the University of Hawaii, and that's probably going to be going away. So we're going to have to shift our some of our focus, and it's not going away tomorrow, but like the writing is on the wall that the astronomy community is going to diversify itself away from Hawaii and into things like here, the space telescopes. So James Webb, it even looks cool. I guess they didn't show a picture of it, but I always like these images, the astronomy images. That's really cool. So, okay. And with all my messages, take care of yourself. If you need help with anything, if you're not having your basic needs being met, if you're having some mental health issues, so I have connections within the university and also and they do in the community. I'm very happy to help you out with that. I mean, mental health is big. Anxiety especially has gone up. So it's a tough time for many people, and so please take care of that. But if you have any issues academically, the content of this course or anything in general, I know my way around the university. So if you need help with anything, let me know. If you want to talk about some of your career pathways, I have an engineering degree alongside my chemistry degree, so we can talk about those kind of things. So, but anyways, I hope this message finds you very well, and if you do get the vaccines, I hope you have a easier time than me, but it's kind of bittersweet because the fact that I had a hard time means that my immune system is pretty strong, and it also means that I'm building great immunity to COVID, and with the vaccines this year, and I think one of the reasons for it is I got the Moderna one, the Spikevax, and the past 2 years they have the dose to 25 micrograms and 2 different strains, so 50 micrograms in total. This year it was one single strain at 50 micrograms, so it was a higher dosage than that. So the Pfizer BNT vaccine, that's 30 micrograms. So it's going to be easier, or 15 and 15 for the past 2 years, but it's going to be a full 30. So it's a little less potent, and people tend to get less in effect because the dosage is smaller. So I'm Team Moderna, and I'm going to go Team Moderna all the way. The flu shot, it's trivalent this year, so it's typically quadrivalent. So they have 2 A's and 1 B strains. They usually have 2 A's and 2 B's. It's the data put out by the World Health Organization and what they recommend. So the flu shot also was a little more potent this year. So I got them at the same time, maybe think about spacing them out if you want to try and limit the side effects if you want to get vaccinated. I recommend it if you're able. So okay, but I'm gonna stop talking, and I hope you have a nice weekend and aloha.